Hi, I'm Thibault, Principal Optical Designer at Immervision since 2005. I designed the first panomorph lens in 2005 for mass production. It was for application in video surveillance and security. At that time, when angle lens design was not that much popular, and lens designer was able to design such lenses were quite rare. I'm a lens designer by training, so I did my master degrees on straight light analysis by using ASAP software in the mid-90s, as well as my PhD in lens design, test, and fabrication of a 3D optical system scanner, which was quite innovative at that time. Sure, I can give you some example of advanced project in metasurfaces, bio-inspired optics, as well as deep learning applied to lens design. Our talented research team gave us the opportunity to explore very innovative aspects for the future. Number one is the bio-inspired optics. So Mother Nature gave us the many opportunity to get inspired. Years of evolution is a perfect ground field to explore. Insects, fishes, birds use various vision approaches that can be used in the near future. So we have a PhD student working on that at the moment. What it means, it really means that we can think about a device or even your cell phone that are inspired by some some birds, for example, like the falcons. If you compare the falcon with the human eyes are only one fovea, so a location where we have a high resolution. But falcons has two of them, so they can see things differently than us with focus on one position, but also have a focus of very high resolution and another position in the field of view. So this is something that can be inspired in the future in the industry, maybe. Metasurface is a second example. So far, metasurface is still a curiosity. We saw some communication from university or research laboratories, but many challenges need to be solved before we can use it. Immervision approach is to be prepared for that, and we prepare for the next step, and particularly by looking on what is required to be able to optimize the metasurface in lens design software to avoid the idea is to avoid a long FDTD calculation. What it means for the future is really that the only way to get eventually a metasurface within your cell phone, for example, is to provide to lens designer tools to be able to use those metasurfaces. And this is exactly the focus we have. We don't say it's going to be there in a year or two, but we will be ready when these things will happen by having all the analysis and design and optimization tools optimized for metasurfaces. A third subject, which is very actual today, is deep learning. We do use neural network in vision, but we want to use them a little bit differently by looking if we can train a neural network to output lens design starting points. Experienced lens designer has a lot of starting points, but most of the lens designer didn't. Consequently, we are looking how to use deep learning to help lens design community. What it does, what it means, yes, it really means that if we succeed on that, we will help lens design community on two aspects, or the lens designer on two aspects. The first one is finding a starting point when you start from scratch is not skills that all lens designer have, and it's more and more this is the case today with new student, and if you don't know how to start a design, you will lose a lot of time to find the right starting point. So this neural network can probably help lens designer to find the best way. The second thing is because we help lens design to find a better starting point in the shorter time, the overall lens design activity will be shortened, and then we will maximize the time from the lens design to the market, to the product. People will not see if the product they have in the cell phone has been designed using a neural network, but at the end, the overall the quality should improve there.